Hello, everyone, and welcome to the webcast. My name is Christine Dorsey Davis. I'm the Executive Director of the Ohio chapter of the American Planning Association, and I am your webcast moderator. Today is Friday, March 15th, and we will be hearing Generative AI Strategies today. For technical help during the presentation, you can type your questions in the Q&A box, and we'll do our best to type answers to your technical questions. For questions related to the presentation, again, just type those in that Q&A box, and we'll get to them at the end of the presentation during our designated Q&A. Today's guest host is the technology division of APA. They've been one of our longstanding partners at the Webcast Consortium, and we are excited to get a hold of today's topic and discuss. Coming up next on your screen is a list of our next two upcoming webcasts. You can register for these and all of our webcasts by heading over to our website, ohioplanning.org/planning webcast. Today's session is worth 1.5 CM credits. You can head over to planning.org, log into your My APA account, and from there you can search by today's title or event number to log those credits. And that title and event number can be found again on our website if you're having trouble looking it up. And again, that's ohioplanning.org/planning webcast. If you're on social media, be sure to like us on Facebook. That's where I post important date or time changes, when new sessions are available to register for, or any interesting tidbits that I'd like to share. And secondly, subscribe to our YouTube channel. We record all of our sessions and post them to our YouTube channel. So if you head over there, you'll find well over 500 session recordings all available to you for free. So be sure to subscribe to our channel so you get notified when new sessions have been loaded for you to view. Again, if you have any questions, just type them in that Q&A box. We don't do the hand raise thing. There isn't going to be any sound for you all. So just type those questions in and we'll get to them at the end during the Q&A. If it's for a particular panelist, it would just help our moderator if you say who it's for too. With that, I'm going to stop sharing my screen and I'm going to turn it over to Kayla. Oh, one more thing. We have some polling questions that we're going to be doing throughout the presentation. So just be aware of that, and the questions will just kind of pop up right on your screen. If you're on a mobile device, depending on your settings, you may or may not see that pop up. So I apologize if you are unable to participate because you are on a mobile device. But otherwise, let's get started. Now I mean it, Kayla, you can go ahead and kick things off for us.
Thanks, Christine.
Sure.
I just want to start off by saying this is a complex and evolving topic. Just set the stage with that. So we hope that everybody appreciates the attempt of today's session. From me, I'm a municipal planning sector employee, and my hope is that the information that's shared with y'all today will give you a chance to observe and access new resources from this emerging technology sector, so you can better use this tech in its intersection with planning to be more effective and efficient planners. I'm going to go ahead and just introduce our two panelists today. David Wasserman. David works at the intersection of urban informatics, 3D visualization, geospatial analytics, and visual storytelling as Alta's civic analytics practice leader. He brings years of experience and passion to applying scientific computing, spatial analysis, and scenario-focused storytelling toward the development of effective transportation planning solutions aimed at improving communities. David has been writing and presenting on applications of AI and computer vision in planning practice since 2019. His work has included webinars and NPC presentations such as Computer Vision and Community Vision, and publications in Planning Magazine, APA blogs, and acting as lead author in PAS Memo 111, AI in Planning Practice, alongside Dr. Michael Flaxman, which I highly recommend you all take a look at if you haven't already. Our next speaker is Norman Wright. Norman is the founder and principal of Parameter, a local government consultancy. Prior to 2023, he served as a local government executive, leading planning, economic development, and several other public services in 2 counties and 2 cities across the 4 time zones of the lower 48. His teams have garnered national recognition with awards from industry groups like the American Planning Association and Urban Land Institute. He's also the author of more than 30 articles and videos through outlets such as the APA, ICMA, and planetsin.com. Next slide, please. All right. So I've given y'all the brief introduction. David will take over technology review considerations and strategies in practice. And then Norman is going to share a live demo with us, which is we are very excited for. And at the end, I'll go ahead and facilitate the Q&A. So just like Christine said, drop those questions in the chat box and we will make sure we save time for them. All right, go ahead and hand it over to David.
Thanks, Kayla. So in this review of the technology, there are some basics that I want to cover first before we go too far, but next slide, please. I think it's important to ground the perspective of this presentation, given all the different views around generative AI. And while I'm sure there is a wide range in the audience, ours is that this is a general purpose technology that planners should attempt to wrap their head around. If you're interested in either side of the spectrum on this chart, we have different podcasts or papers that we can recommend for you. Next slide, please. And now that we established that, I wanted to ground us with some terminology. These definitions are largely as long as they are, so that when we distribute the slides for this later, you can come back to them. But at a high level, when we're talking about generative AI, we're talking about models or techniques that generate data. If we talk about foundation models, we're talking about these huge general purpose models that often specialized models can be built from. And large language models can be thought of as a special purpose, either foundation model or smaller model that generates text. Fine tuning is the process by which these models get specialized to do one task or another. And prompts are the inputs to these models. Next slide, please. And so I want to start with how we got here. To me, this is a story of complexity and scale. Since the earliest AI experiments of the 1950s, machine learning, a technique by which computers learn from data, couldn't do that much until the 2010s when we had the deep learning revolution. This gave us a lot of recent advances in AI that a lot of us now take for granted and see in our technology today. It includes being able to convert speech to text, to extract content from aerial imagery, such as crosswalks or tree canopy, or being able to look at safety analysis through the lens of video analytics. And in around 2016, we started to see really large scale models. These models take absolutely massive amounts of data and compute to train. And as just in terms of financial resources to develop them, it's worth understanding that they can cost hundreds of thousands of dollars or even millions just to train advanced models like ChatGPT-4. Practically, this has a direct accessibility impact on the technology, typically making it so that massive companies are the ones that can afford to train these things. Next slide, please. And we now have these LLMs trained on massive data sets from many different sources with many different groups trying to compete to make ones of different sizes and specialities. And the sources of data that are inputs for these models are largely derived from the digitalization of the human experience, whether it's books, research databases, or crawls of the entire web. A lot of these things end up being inputs into these models. And from that data, they've learned patterns, grammar, syntax, context, semantics, all these different things that help them generate coherent and contextually relevant text. So they can classify responses, they can classify text, they can generate responses and even translate between different languages. And as we've seen different types of model sizes be created, I think it's important to understand that the models can partially do this by being so large. They're effectively compressing huge amounts of information very efficiently. But when we when we're looking at even some of these small models, it's worth understanding their scale. For example, Mixtral is a small model, depending on how it's represented, that can be somewhere between 25 to 180 gigabytes in size, just on disk. Next slide, please. And one obvious application of these models is the ability to synthesize public feedback. And part of my work at Alta, one of the things that we tried to do was employ ChatGPT, for example, on a statewide active transportation plan survey responses. And we essentially leverage this tool to look at around 4,000 open-ended responses. And we use the model to summarize each of the comments into 3 words to construct a word bubble from those summaries. Next slide, please. And we found that these models could be used to help take that type of summarization further when we started trying to classify these comments based on how well they aligned with different project goals or themes. When we cross-tabulated classifications of comments based on their alignment to project goals, we would look at them relative to pre-selected survey responses related to whether the comment was about pedestrian safety, bicycle safety, etc. And what we found, for example, was we were able to look at and tabulate that, as an example, 22.4% of comments that were categorized as pedestrian safety had themes within the comment that were related to connectivity. Next slide, please. So beyond natural language, we're also seeing that image generation is a technology that has tons of applications within urban design and other aspects of planning. And this is a technology that's dramatically improved over the last 10 years, going from crude images with obvious artifacts to ones that look just like photos. Next slide. And more recently, new models can now do video too. You just gotta hit play. This is an example from an application called Sora that was recently unveiled by OpenAI, which can create realistic scenes from text prompts. And what's impressive about some of what's in here is its ability to create pretty continuous flow of images between each segment of the clip, where previous experiments with using generative AI and video generation were much more buggy. Next slide, please. Oh, yeah, there we go. And some of the top-end models can now use both languages and inputs as language and images as related inputs. These multimodal models have pretty immediate applications in planning. When Meta open sourced a foundation model that could identify the outlines of arbitrary objects and images, such as trees or sidewalks, it didn't take much time for the geospatial community to find remote sensing applications for this model. Every high resolution aerial image is now dramatically more valuable. If a single general model can use them theoretically to let sustainability professionals measure tree canopy cover or transportation planners to map crosswalks. Next slide. And what a lot of people aren't very familiar with is the very rapidly evolving open source ecosystem developing related to these to a lot of the language models and generative AI image models as well. That's starting to be more and more apparent. Since Meta open sourced its llama models, not only have generative AI conferences started to bring many live llamas into their proceedings, a rich ecosystem has developed around those models and others to enable smaller but potentially still effective models for some applications. Some models can be run on modern laptops and computers, albeit a little slowly. And if if fine-tuned, some have found that these small models can be effective for narrow applications, but their results are not going to be as comparable to the results of top-line models in many cases. However, even with that said, at a certain scale, within the open source sphere, some of the larger open source models can be near the effectiveness of models such as ChatGPT-4, but it's hard to establish true benchmarks for this technology as things stand. Next slide, please. Additionally, the software community got really excited about all this, and now there's a thriving ecosystem of either freeware, paid, or open source software that lets people download and use these models pretty quickly. They can require substantial hardware to deploy effectively, but many can run on a laptop, as mentioned previously. One very approachable app is LM Studio. This gives you an interface where you can find new models and start chatting with them pretty quickly. And again, if you have the bandwidth to download a small model that could be 30 gigabytes in size. Next slide. So that was a brief review of the technology, where things stand, what are some applications that are emerging. I want to talk about some considerations for planning practice, and that's what this section is about. And its considerations more broadly as well. Next slide. One is that prompt construction matters. There's a lively field of research about the importance of prompts, but it seems to be important to getting useful answers out of these things. And while there are entire guides or papers that could be found, one general consideration is that it helps to be specific. These models perform well when you clearly state the requirements that you're trying to fulfill to avoid ambiguous responses. It helps to provide context that can guide a response. Norman's demo provides a very sophisticated example of how that's important to get useful answers. It helps to ask for process. There's some evidence that both accuracy and the quality of responses can improve by evoking what's called chain of thought reasoning. And it helps to define the format that you're looking for and give examples of what you're looking for to these models as well. This is one example to the right where I provided it sample code for a script that I was looking for, and it then provided me a template that was very close to it. Next slide. And while prompts matter, and while sometimes these models can give you exactly what you want and save you some time if you're editing something or trying to write a memo, other times they are wrong. They can hallucinate, and what's even worse is that sometimes it's not obvious that they're wrong. They're very good at giving you believable BS that you have to spend a bunch of time fixing if you miss it on a first review. And this type of slot machine productivity kind of feels like you might take one step forward and two steps back. We can imagine a scenario where we're developing a memo to inform the placement of something like protected bike lanes down city council. You know, if we assume manual write-ups have more or less a linear scaling with time in terms of the relationship between the output that you create and the time that it takes to deliver it, we might imagine someone using generative AI to recreate the same thing has maybe more of a stepwise productivity curve where we're not producing anything while we're trying to get our prompts just right. But at some point we might get something that provides us a lot of output that we couldn't create otherwise. But there's a scenario where if we get low quality outputs or something subtly goes wrong, we spend more time trying to build back up trust if the mistake lost us trust in the process, or trying to be more careful about what we write next given that mistake. Next slide, please. And I think another concern here is its bias. Machine learning researchers, and I would say it's one of the largest ones because it has to do a lot with the types of subtle framing that these models can present to people. Machine learning researchers primarily define bias outcomes from applied as it relates to machine models in two ways. One is the potential for allocative harms, where resource allocations might preference or punish a group that might come from decisions from models like these, and also representative harms, how these models might perpetuate stereotypes across protected classes, for example. And generative models have been shown to show substantial degrees of bias across protected classes. This is extremely visible in image generation. And while safety features might mitigate some of these issues, they are definitely not likely to erase them. Planning requires us to think about how policies and public investment shape the potential pathways for community futures. These models generate content on past data, including aspects of the past that we might not want to repeat, or aspects of the past that are grounded in a framing of problems that we no longer hold. If planners aren't careful, we can recreate and cement old modes of thinking that we could lock in with institutionalized generative systems as part of our work. And I think it's just an important reminder that prediction is a mirror. As professionals, we really need to pay close attention to how these models are used to plan common futures within our communities. Next slide. And I think Bloomberg did a very good illustration of this in terms of how this bias can appear in at least open source generative image models, where they used models such as Stable Diffusion to generate thousands of images of people given a job title. And what they found is when they generated people of different professions that were high paying versus low paying, that when the image sets were generated for every high paying job, the subjects tended to be dominated by lighter skin tones, while the subjects with darker skin tones were often associated with lower paying occupations. Next slide. Similar patterns that appeared for race were also very common for gender. And while I'm not showing a chart that relates to how this carries over to text models, when Microsoft researchers were evaluating ChatGPT-4 before a lot of its safety procedures were put in place, they also found that this type of gender bias was present using similar techniques in how the text was generated by that model. Next slide, please. Additionally, bias shouldn't be too much of a surprise, because many of the training data sets for these models are roughly filtered indices of the internet. This means that they're commonly just CSVs that are just links to images with descriptions and other metadata attached to them, such as how large the image was, etc. Many of the image generators use for their base models these training data sets, or at least seed them throughout their work. Reviewing some of the images and their tags made it very clear why OpenAI spent millions on workers trying to clean these open source data sets. And it's also not surprising that researchers such as those at Stanford have discovered that these data sets can often have images of things we don't want them to recapitulate, such as child abuse or other similar content. Next slide, please. And this is definitely an evolving topic here, but as it stands in the US, you can't copyright solely prompt-based images for many applications, and for a lot of work, both by planners, but also potentially within the public sector, that might not be an issue in some cases, but it could be an issue in others. And there's still multiple cases working through courts to see whether the underlying technology is fair use or not. In general, it seems that these cases have been mixed with most generally not making firm declarations that this technology is legal, but many generally facilitating or enabling the status quo. But we're starting to see more active legislation by the EU. I think this week they passed their AI Act, which, for example, requires AI-generated images be labeled as such. And also best practice citation from guidance such as MLA has said that the use of AI should be declared as part of publications. And it's likely AICP certified and other planners more generally should take note of that as well. Next slide, please. We're starting to see also that these models have the potential to influence public discourse. And as a result, they might be able to fuel misinformation on planning issues at scales that might have been difficult to do previously. We're already starting to see the political applications of the technology grow. I don't want to talk about it too much, but generally bias and representation is a key consideration when we think about how the technology is used in this way. And I think generally the local politics that the local politics that we're going to see potentially come out of this type of discussion of the technology is likely to evolve, and one might hope it might just be the new spam. When we see this content, maybe people become more discerning in figuring out when to ignore it, but it's not clear that will be the case. Next slide, please. Additionally, it's when people start using this technology to create agents that act on their behalf, we're starting to see legal cases come forward where organizations can be held to account for their bots' actions. One example was Air Canada was forced to honor a refund policy that its chatbot invented in small claims court. That led to them taking the bot down. Next slide, please. And in another, an auto dealership sold, for example, this was not a legally binding sale, a Chevy $70,000 car for $1. While it didn't lead to a sale, it did embarrass the chat provider Fullpath extensively. Next slide, please. And anything about this topic is speaking or talking about this topic, this is an area that's of development that's incredibly fast paced. Lots of things are going to change. But one of them that's worth noting is that the user interfaces from research, like cutting edge research, aren't getting to a place yet where they're going to be firmly integrated. I think with tools like Copilot and Adobe Firefly, we're starting to see some of this technology get more integrated into the technologies that planners use day to day. But the user interface is still kind of stuck in this chat-like pattern just based on how these models are designed. But that's an evolving topic. And one area that I think planners should think about more collectively is where can we use these models to be more specialized to facilitate the types of work that we're trying to do and better our communities more proactively and productively. Next slide, please. Okay, so I'm going to go real quickly into strategies. And just generally, this is a quick list of resources and potential strategies that planning organizations can consider for their deployment for generative AI. Next slide, please. The first one is that we should think where the reversibility principle what role it should play in our deployment of this technology. And it's one of my favorite to recommend when we are considering deployment of any new technology. And that principle holds when we consider deploying a new technology, we should prioritize the application of products and processes whose negative impacts will cease when withdrawn. And there are concrete examples of this in planning where we can imagine where some applications of generative AI are more likely to be reversible than others. And for those that are more in the irreversible category, these are areas where organizations might want to prioritize their guidance that they give to their staff and others working in their communities. In practice, every organization will have different tolerance thresholds for the risks that they want their staff to take, but this principle provides a good framework to evaluate where guidance is needed for specific types of decision making. Next slide. Additionally, there needs to be proactive steps by the profession to hold each other accountable as we continually see planners leverage this technology into the future. This means collectively, every planner should declare the use of AI, use it to improve judgment, not replace it. We need to come up with procedures and processes to check the outputs and disclose the limitations when we're using this technology. And it will help to proactively educate ourselves to avoid using these tools without understanding them at a basic level. And I think also it is worth understanding that if we're using these technologies through APIs or other interfaces with technology companies, we need to make sure that sensitive information is protected whenever we're using them. Next slide, please. So the other consideration is that before a lot of the discussion around generative AI happened, there were other approaches to planning automation in our work that were being discussed or pursued that still potentially have value. One publication that I think really underscores this was the Planning Institute of Australia's concise document on the use of AI in development assessment, where they very clearly contrast two different approaches to planning automation in practice. One that we can imagine being driven by digital codes or open data specifications and rules connected to them that evaluate projects more procedurally, or machine learning approaches that are more probabilistic inferences based on prompts and more open-ended inputs. Both have advantages and disadvantages, but they're a reminder that since the pandemic, planners have made strides in updating their processes to be more nimble and coordinated. And it's worth still exploring those avenues of automation in our work, where we're just working on how we communicate with data between different parties, whether it's different disciplines or different agencies or members of our own organizations. And I think there's also a potential future where there's a hybrid of these, where it's very possible these models can help us create emergent specifications or commonalities in communication, but that might be a different presentation for another day. Next slide, please. Finally, generations of planners have a very rich tradition of not reinventing the wheel on policy. And there are increasingly examples of both policy guidelines for public sector employees and policy resources from both the American Planning Association and the OECD that are worth reviewing and considering. The APA Technology Division encourages everyone reading our brief open letter on ethical practice as it relates to generative AI technologies. And I personally recommend APA's resources on the matter, and also a very relatively recent OECD initial policy considerations report on generative AI, which includes tidbits such as the selected research findings you see to the right. And with that, I'm going to pass it off to Norman to talk about strategies in practice and his demo showing how custom GPTs can be used to help with staff reports. So I'm going to pass it off to you, Norman.
All right, thank you, David. And thank you also for providing us all this great foundation at the start. Kayla, I want to call on you real quick if you can unmute. Can you tell me how many poll questions we have before the demo? And I think we have one poll question after the demo. Is that correct?
I believe it's 3 before and
Okay.
2 after. Yeah.
Okay, very good, very good. I'll call back to those poll questions here in a second. Thank you, Kayla. So, in talking about strategies in practice, what we want to do is we want to take everything that David has just shared, from the ethical implications, the practical implications, the research, the best practices, the keywords and concepts, and try to assemble them into into a practice here. And to do that, I just want to say at the start that I am not a software developer. I am not a data scientist. I'm a planner, just like everyone else I imagine on this call. And so the things that I'm able to do right now are because of the resources like the ones that David's provided, as well as some resources elsewhere in the APA. So on the screen here, we have 2 particular resources that I think can be worthwhile. We have a 2-part APA Passport series on using generative AI for image creation. And then apologies for the shameless plug, but I also wrote something on this last October for zoning practice. And in both cases, you get practical examples of how to use this information, these tools rather, to get the information that you're wanting to develop. Again, whether it's images and image creation through everything shown on the Passport series. I also do a little bit of it with Midjourney, and then in ChatGPT, there's a bit in the zoning practice article about how to create draft zoning policy as well. So these resources are here to help everyone start to develop the same sort of capacity with these tools that I, as a total beginner, have started to develop, and that others are doing as well. So we're all in this together. And I just want to make that clear that these resources will help all of us move further along. So I've got a challenge here that I'm going to try to meet with our demo. And that challenge is to create a staff report. I don't know how many of you are familiar with some of the common uses of ChatGPT, but right now, a lot of it is around chatbots. I hear or I see the occasional chatbots that do the things that David showed earlier of these really interesting examples from Air Canada and from a Chevy dealership. Well, I also see occasionally chatbots that are trying to be utilized with customer service requests or with call centers or in local government even to help people try to orient around particular issues at City Hall. But that was an initial thought for our demo, but in talking with Kayla actually during our preparation, she challenged me to actually come up with a staff report instead, because chatbots are one thing, okay, and there's a lot of threats around those and risks around those, like David mentioned, but a staff report, that's a whole other mountain to climb, because I don't know about you, but staff reports are very difficult for me. You can have all the application information, you can have a case very well understood, but when you face that blank page and have to try to write out a report, that can be a very time-consuming and stressful process. And so we're going to use ChatGPT to do this. I'll talk a little bit more about it in a second. And I just want to illustrate here the basic idea through these parameters that you see on the screen. So every one of these parameters is basically a constraint. And each one of those constraints further tightens and narrows the function of this particular model so that it really just does one thing very well, okay? So it's going to focus on variance requests, not just any staff report, but a staff report on a variance case. It's going to incorporate all the relevant application data from the applicant who submits the request. It's going to compare that to the local zoning, and we're going to use an actual active zoning ordinance from an anonymous town in North Carolina, and it's going to generate a report. And that's a constraint, that's a parameter right there. Generate a report and output that fits the key themes of what you would see in an existing staff report. And then be ready, GPT, be ready to answer any follow-up questions about that particular report and the case itself. And in particular, be sure to do so while utilizing just the North Carolina body of land use law knowledge. So those are major constraints, along with the final thing here, which is to assume the persona and expertise of an AICP certified planner. These are all, again, these are ways to do what David referred to earlier as fine-tuning a model in order to make it do exactly the sort of thing that you want to do. And even when you fine-tune it as much as I've fine-tuned this, you'll still get some funny things now and then that I really hope don't show up in the demo, but it might. So with that said, before I continue further, Caleb, will you pop up our first poll question?
It's going to be me. Christine is back.
Oh.
And I am going to pull up that first poll now.
And
I just launched it. Go ahead, David.
I was just going to clarify, Norman, like the way that the custom GPT works, fine tuning is a sometimes fine tuning can refer to actually retraining the model on new data. But I think with the custom GPTs, what happens a lot is that we're providing it a very custom knowledge source that it's able to use to guide the response. And I just wanted to, I don't know, I'm being a little bit pedantic here, so I'm gonna be quiet. But that's kind of one of the things I just wanted to say.
Be pedantic all you wish, David. Yeah, and we'll our next slide will show a little bit more of the fine detail of what David's talking about there too. So thank you, David. Our first question here for the poll: have you used the free version of ChatGPT? Yes, no, unsure. You may not know that you have or haven't, but if anyone feels free to answer that question on our poll here, it would give me a sense of our audience and their familiarity here.
Okay, I'm going to go ahead and close her up and share the results. So 52% say, yeah, I've used the free version. 47% said, nope. And 1% is like, I don't know. Maybe, I don't know. So there are results on that one.
Excellent. And then let's do our second poll question too while we're here.
You got it.
Yeah, thank you.
I think we're gonna do 3 here, and then you can do your simulation, and then we'll do these last 2. So have you used the subscription version of any AI software? We'll give y'all a few moments here to answer that. And to my panelists, you're not allowed to vote. So that's, if it doesn't show up for you, that's why. But it really is running. Give it another moment here. While I have some airtime, just a reminder, folks, if you look in the chat box, if you were having trouble locating the session for CM credit, I put the direct link to recording or to logging the session for credit because you couldn't search for it. It just wasn't popping up. So, and we're also recording the session and we'll have the slides. You can just go to our website. Okay, here we go. Have you used the subscription version of any AI software? 12% say yes, 87% say nope, and 1% say, I don't know. All right. I think this is our last question before we move forward. Have you used any generative AI to help you with tasks at work? Yes, frequently. Yes, sometimes. Yes, rarely. No, unsure. Give it another moment here. Folks are really thinking hard about this one. So it's taken a second to get all of our responses in. All right. All right. I'm going to end it. Here we go. Share some results. 5% say, yeah, frequently. 13% sometimes. 20% rarely. 61% nope, never done it to do any tasks at work. And 1% I don't know. All
That is
right, back
excellent.
to you, Norman.
Excellent. Thank you, Christine. And this is very, very helpful. So, yeah, for all who have not used any form of these, particularly these large language models, I hope this demo will show you a little bit of what can be possible with a good bit of work. And for those of you who've used the subscription versions, particularly ChatGPT, some of this may be familiar to you. And if so, and you're very close to being able to do some of the things that I, as a non-expert, am able to do in this demo. So David mentioned earlier a bit about some of the key points for making these models work. And so I want to talk about the model we're going to use today. It's called the VSR 3000. This is very whimsical. This is very silly because this is not a commercial grade product. This is solely for our demonstration purposes. And so this is known as the Variance Staff Report Maker. I asked also the ChatGPT to please provide an avatar for this model. And so I said something like a cybernetic bureaucrat. And, you know, we get our image here, which I guess for ChatGPT, and it's good enough for me, is the image of a cybernetic bureaucrat who's going to review these cases and issue a report. And by the way, the 3000 means absolutely nothing. VSR 3000 just sounds like futuristic to me, so why not, right? But again, it's all to just stress the point that this is not a commercial product at all. It's just for us to learn a little bit here today. So, okay. In configuring this in the sort of ways that David was describing earlier, it's very important to understand that ChatGPT, in its subscription level service, offers you the opportunity to create custom GPT models. And those customized models are based on the instructions and the parameters and the limitations that you want to provide it. I referred to it just colloquially as fine tuning. There is a little bit of a different technical meaning to that term, but for here today, the tuning, shall you say, or shall I say, is to say that this VSR 3000 follows very specific instructions that I have embedded in the left-hand column that you see on the screen here. Those instructions fit the parameters that we talked about in the previous slide, and it utilizes a particular zoning ordinance that I just loaded in as a PDF. It also utilizes custom PDF documents for the variance applications that we're going to use. And those PDF documents are annotated in a way that really makes it easy for the GPT to read and compare to the zoning in order to generate a result. And then finally, one more thing here is that I have a prompt library, which is the series of standard commands that I now copy and paste into the GPT to make it work, because these prompts can be a real trick if you it just very, very tricky if you can't get them just right. So over multiple tests and trial and error, we get a demo that can do this, I think, reliably well. So with that said, let's go into the demo itself. So again, for those who haven't used, say, ChatGPT, for example, at all, I'm going to stop sharing this screen, and then I'm going to load up the actual interface here from the web. Okay, and now I'm going to share the screen again. Just one second. Okay. And David, I'm looking at you for a reaction. Can you see my screen? All right, thank you, sir. Okay, this is the ChatGPT 4 homepage, essentially. And from here, you type something into the interface like you would into a Google search, and then you get results. It's really fun, really great. But we're going to go over to our custom GPT, the VSR 3000. And again, this is a GPT model for North Carolina, particular North Carolina zoning ordinance, in order to review a variance application or an application for a variance. Okay, I'm going to load up the actual application that I have put together into this GPT in a second, and then I'm going to put a prompt in, and then we're going to run a result and see what happens. So first, let me go ahead and load up one of the tests here. So I'm not going to go too much into the specifics here because, we're doing a breezy, quick demo for today. But the PDF that I just loaded in has been customized based on what you would expect to see from a variance application. It's been put into a particular format that's annotated very simply for the GPT to read. And that is again compared to the actual zoning ordinance that is configured to this GPT as well. All of that might sound highly technical to some of you, but I promise it's not as hard as it seems. It really isn't, especially again, for someone like me to be able to do. But now I'm going to take, and I'm going to put in a prompt here for this request, and I'm not going to run it just yet. We're going to talk about the application first, and then I'm going to run it. So I copy and pasted a prompt into the bottom of the interface here where you can see the command line. And let me talk a little bit about the actual request. This is a variance request for a city where they have what's known as the R2 zone. That's a single family zoning district. And in this district, someone has just purchased a piece of property where they want to have a variance to the building height of this R2 district and the front setback of this district. The front setback is 25 feet. So any building is supposed to be 25 feet setback from the property line. And the building height, if I remember correctly, I think is 35 feet. That's the maximum building height, I believe, within this envelope. The person who's applied for the variance actually wants a variance for both of those items in order to build a single family home in this district. So far, so good, right? But here's the trouble. They don't want to just build a home. They want to build a mansion. They want to build a 20,000 square foot, 8-story building, or I guess it's a home. And so this is going to be an extreme version of a variance request. And they're seeking a hardship argument here. And we're going to see if VSR 3000 can recognize that this is kind of wild and crazy. So here we go. We're going to run it now. So the hamster wheels are running in the background, and VSR 3000 is searching all of its files and data, and now we get our report. So as you can see, I'm just going to talk as it generates. The report here starts to structure the information from the application form into summary data about the property itself, and we're using a real address, but we're using an anonymous label for the city. We're not going to give away the city's location. Meanwhile, it's got me as the applicant, it's got the date of the application, and it's got the proposal summarized. As it goes through, it starts to talk about the various themes of what you would see in both the application request as well as the staff report, which is findings against the criteria. In this case, the criteria for a proposed hardship, the criteria for harmony on the general purpose and intent of the ordinance, criteria on public safety and welfare. And what do we find as the end result here? We say that based on the findings above, it is recommended that this request be denied. The proposed construction substantially deviates from the zoning ordinance intent for the R2 residential district, and the applicant's hardship argument does not meet the criteria as defined in the zoning ordinance. Again, this is an actual zoning ordinance for an actual address for what could be a hypothetical case. My favorite part about this example, though, is that not only did the GPT run against the zoning ordinance and run against the code and think about hardship and all that stuff, but it could also make some nuanced interpretations about character. So for example, the fact that this is an 8-story, 20,000 square foot residence that's being proposed demonstrates that this is a significant deviation from the intended character and density of the residential district. Now, I don't know about you, but I can't really write that any better, and that's exactly what I would want to write. So there's two important things to keep in mind. This is a very basic case, and this actual final report is still a very basic draft. It's useful for me. It gives me a chance to not have to be stuck on the blank page. It gives me something to use. And as someone who's been a planning director for 14 years or so, what I like most about this is that this empowers or would empower my staff to be able to start with a solid first draft that we could then refine as needed in order to be able to have an effective report at the end of the day. This was generated in what, 15 seconds? So the productivity's there. That's really nice to see. And for all the limitations that we do need to cover, this is still a pretty good, pretty useful first step for the demo. So I'm going to do one more case. I prepared 3, but for the sake of time, let's just do one more for right now. And this next one is going to be for the same zoning, the same address, the same town, but instead this time the request is slightly different. It's a request this time for a front setback variance again. Remember, the setback in this case is 25 feet. And in this instance, this is a person who wants to have a variance on that front setback to go from 25 feet to 5 feet. And what's the reason? In their case, in this application, it's going to be because the back part of their property has a downward slope that is about 8%. Now, 8% in Western North Carolina might as well be 0%. It's almost flat. So there's a real judgment call to be had here. But what the variance request is going to say is that due to the topography of the area, I believe the applicant that I'm going to suffer an unjust hardship if I have to grade and alter the terrain in order to build my home. And this person's home that they want to build is a 3-story, 2,000 square foot home. So they're looking for just a more of a regular home within this district. So again, to me, there's a bit of a judgment call here. Is 8% sufficient for a hardship? In some places, I think it is. In other places, I'm not so sure. So let's see what our VSR 3000 says. First, we're going to put in the actual application itself. Again, this has been customized as an application in order to work as an input for the model effectively. And now I'm going to give ourselves the prompt. There we go. And let's see what we get. All right, it's running a little bit faster this time because we've primed the context from the first staff report. You're going to see again, we're getting the same output as before with the summary information and then the basic summary of the request itself. In the application, the applicant has to explain why they feel justified with this request. And so the GPT is going to balance that argument with the criteria within the actual zoning ordinance itself. And then it's going to produce these findings. So as you can see, if you're reading along here, under proposed hardship with staff findings, the GPT is already being a little bit sensitive to the fact that this is about the topography, something that can't actually be controlled necessarily. And so our recommendation is this: given the considerations above, it is recommended that this variance request be approved. The unique topographical challenges of the property create a genuine hardship that justifies a variance. The proposed construction with a reduced setback maintains the spirit of the zoning ordinance and does not negatively impact the neighborhood. Now, that negative impact, again, is around the question about a 25-foot setback versus a 5-foot setback. And so that is actually taken into account further up in the text of this output. And I'm not going to get into it just because we're just going to move along here. But I personally, though, have a question for this GPT. Okay, if 8% is sufficient enough to consider a hardship, well, where's the limit? Where's the line? Where does it not become a hardship? So I'm going to ask this question. If the slope was, let's say 1%, would that also constitute a hardship that would justify this variance? Question mark. And let me fix there's always a typo when people are watching you type, right? Okay, so I'm asking a question like I'm a member of the Board of Zoning Adjustment. I'm asking a question now to the GPT like it were a staff person. I'm saying, okay, 8%, that's a hardship, fine. But if the slope was 1%, would that also be a hardship? Where's the limit here? Is 1% that limit? Let's find out. Let's just see what it thinks. Okay, so a slope of 1% is generally considered very slight and might not by itself constitute a significant hardship, justifying the variance under typical zoning ordinance criteria. Okay, so it keeps going on here to talk about this. And if I were in if I were in a meeting and someone asked me this question, I would just say, yeah, 1% isn't enough. That's all I would say off the top of my head. But with the model here, I can get a lot more context and detail and a lot more of my logic and intuition that I already know. I can get that unpacked a little more fully so that a layperson can get a little more detail and color into why I say that 1% is not a hardship. So that I think is a pretty good example of also the kind of follow-up that you can have, the questions and answers once the context is set with a case that's been shared. So there's a lot more that can be showed here, a whole lot more. But I'm going to stop right there for the sake of our time and save some time for some Q&A and also do some key follow-up at the end of our presentation. So I'm going to stop sharing for a second, and then I'm going to come back to our presentation itself, and we'll close things out. And as we start to close things out, a key question here, Christine, is that final poll question. Can we pull that up? Okay, so folks, within the next 2 years, how likely is it that your municipality organization will utilize generative AI in the workplace? I mean, we're sitting here talking about something that is already, I think, somewhat impressive for what it can do. And the worst models that we have are the ones we're using today. This is just going to continue to get better and better and start to be more integrated into enterprise software in the ways that David described earlier. So this is an important question for all of us. Within the next 2 years, how likely is it that your municipality organization will utilize generative AI in the workplace? Okay, and our results are in. So 27% feel that it is very likely to see in 2 years. 36% say it is likely. And then the minority of our group is saying that it's 12% unlikely, 7% very unlikely, and a lot of people, 17%, say it's unknown. This is a solid spread. I think this is very representative of what I think is everyone's general thoughts around this conversation. I think we all, as a majority, feel that it's likely. It's even very likely. Some of us don't know at all. We don't know enough to say. And for places where it is unlikely, I actually totally buy it. I think that it is unlikely and very unlikely in some places, just like the adoption of the cell phone was very unlikely in a lot of places for a lot of people for quite a bit of time. So these things run on a curve where you start with early adopters and then an early majority, and then it tails off into those who wait for those folks to adopt this technology, and then others follow soon after. And so that response is fascinating and very helpful because I think it does reflect the general course of where we're heading. So with that live demo complete, I want to now finish up with a couple more slides here of note. So the application here of this particular tool for this particular job is surrounded in a few key points. Quality inputs are very, very important when it comes to using a large language model. That includes the prompts that are mentioned on the third bullet, as well as the quality inputs that are mentioned at the top bullet. So you have to structure data in a way that is easy for the large language model to process. And once you understand how to do that, it's easy to repeat that process and continue to work very well with the model, but that's still important. Another important thing, and this is not just for the quality of the output, but also for managing the risk of these kind of tools. They're very powerful. Narrow the focus of what you're going to use these things for. You can create many different custom GPTs of the sort that I just showed in the demo. And you know, you could have a GPT that's for zoning staff reports, like a rezoning request, a variance request. You could have one for let's say generating comments from all the staff in an initial review for a building permit. there's a lot of ways in which these things can work, but it's very important, I think, especially at this stage, to only have them do that one thing so that you can always make sure that you can test the quality and the reliability against that particular application. And then finally, context is always crucial. So when working with these models, you want to start by setting up all those parameters for the model that we talked about. Then you want to incorporate the application itself. You want to get those results, and then you want to work from there with questions and answers. There's an order of operations here that, again, is very basic, but also vital to understand in order to use things in the demo like we just did today. And finally, earlier, David showed this slide, and this is a very important slide for us to all consider. This slide shows us, I think, a lot of what we saw in action with the demo. Again, it's a very brief demo, but we can already see how it can accelerate development of our tools. It can boost our productivity to give us a great first draft, in this case, of a staff report. It can be actually quite good for research assistants in the ways that I didn't quite show today, but that we've seen in other uses of this demo prior to now. But there are weaknesses, of course. One weakness that I didn't show is that I had an initial response to one of those cases that we did, where the recommendation by the VSR 3000 was, we recommend approval of this variance request on the condition that the applicant talks with their neighbors and gets their neighbors' support. That's a terrible idea. That's not the way that this is supposed to work. But VSR 3000 didn't know that until I said, that's a terrible response. Don't say that again. And then it's like, okay, we won't do that again. But it does take a little bit of a recognition that you're going to get unpredictable or incorrect outputs at times that you have to then refine in the way that we're talking about in this section. As far as opportunities, as I already just said, these models can be tuned to many different functions, and that's a very nice thing to consider and explore as we move forward with this technology. And then finally, on threats, I just want to touch on this very first one here, skill atrophy risk. I'm already somewhat not very good at writing a good staff report, and this is going to, a tool like this is going to enable me to continue to not be very good at writing a staff report. I think that's okay. I mean, as a planning director, I'm okay with that so long as we continue to make the second, the third, the final drafts the best they can be. So a skill on the front end is not too important to me, but there are other ways in which these tools can be applied, not beyond staff reports, of course, where we can start to see some of our skills start to erode the more we become reliant upon these tools to do a lot of the job for us. That also can lead to the labor market disruption that's talked about on bullet number 5 or 6 there. And so there are some real strengths, weaknesses, opportunities, and threats that we really need to consider. And for all of the value that this can bring, all the utility, we've got to keep the balanced view here that you see on the slide. So with that, I think we're in the Q&A. So thank you all very much.
All right, so David has been very active in our chat. So please check the answered questions because David's got some really good responses in there. Given that we're running a little short on time, I'm going to focus on the questions that have not yet been answered. We're going to go ahead and start with some of the VSR 3000 specific questions. So Norman, probably mostly you. David, feel free to chime in.
I
Is
I was
V-
just I was just going to say, Norman, there are multiple questions where there was some interest in specifically what the PDF input looked like.
Yeah,
If you just want to
okay,
open that up and share your screen, both on the
totally.
ordinance. I just think showing your screen real quick on that would just answer multiple of those questions, and we can
yeah,
get it out
there
of the
were
way and we can
several
dismiss them.
in there.
Sure thing. Okay, so just a second. I'm going to pull up. I can't stress enough that this is a very basic thing. So you're about to see, and I'm glad that someone asked this because I did want to show this. You're going to see that this is fairly intuitive. Okay, so okay, let me share the screen for the variance application. So, all right, so okay. Okay, so right here, this is a PDF. This is the variance application. And for this particular town, they have a variance application form that has these basic questions, very good questions, that then elicit the responses that you see throughout. So we have the key information about the location, the address. We then have within the application document itself, this type of information here that you see about what constitutes each of the criteria for granting a variance. Then you have this section where I provide a response. And when I provide a response, I always annotate or prefix that with I, the applicant, request this variance because the blah, blah, blah. And it's a little bit funny, some of this in here. I did this for humor purposes, but anyway, you see that there is the bold language that is from the application itself, followed by the regular non-bold language that is the applicant's response. And you continue to see this go throughout in what is basically the same shape, flow, form of the actual staff report format itself. So that's that part. And then let me see about, just one second. Let me see about pulling up my, all right, I'm trying my best here, folks, to keep this generic and not highlight the particular town, but the town in question, their particular zoning ordinance involves it's 101 pages, and in this case, it is a fairly straightforward document. You know, this is not, say, the Denver form-based code that's got 100 and something districts and a lot of wild formatting. So we're very fortunate in this case to have an ordinance that is actually straightforward in its structure, straightforward in its content, and that's very, very good for this particular ChatGPT to be able to work. If you have a very complex ordinance, like say again, the form-based codes that you might see for Denver or large codes in places where I've been working for a while as a planning director, that's going to take some prep in order to make it just right for the GPT to be able to process. But it is all doable in just the way that we showed with the variance application that gets transferred into the PDF form, but it does take some time to make it work in those other applications. I hope that helps.
Thank you, Norman. One thing I did want to add, one of the questions I think I want to clarify, we don't recommend at all, and I think from the demo, we're not trying to recommend at all that we're replacing planners with artificial intelligence. Like I think that's something I just want to say very clearly. What we're trying to show is that this tool has capabilities that can augment our work. We're also trying to communicate that it's imperfect, and that if people are thinking along those lines, it's a very dangerous line of thinking. And also I think there's a lot that can be said for just understanding some of its wider capabilities than what you might see in just the free products, which is kind of what we're trying to illustrate as well. It's not, the demo is largely just to provide an example of how one could structure both a knowledge base, a set of inputs, and other components to approach a problem. Norman, do you want to add anything there?
Oh, there's so much that can be said, but yeah, as someone who's overseen planning departments, when I look at this, what I see is an ability for my beleaguered staff who have way more reports to write and way more calls to answer than they have time. Now having a tool that can help them actually meet more of their community's needs with the time that they actually have. So I don't know about all places, but anywhere that I have been, everyone has way more on their plate than what they can handle, and they need some kind of assistance, some kind of tool, some kind of software that can help them be a little more efficient and productive. And it's in these little areas where there's just, frankly, where there's just drudgery. It's so tedious to start with a blank page and try to write a report, or even worse, to write a report from an old report and then try to catch all the typos and fix it all up. there's so much there that is actually we're empowered to do already through the word processors that we have, like Microsoft Word, but there's still tedium. And a tool like this in this demo, or other tools like it that leverage other forms of AI, can actually make us better, faster at what we do, and thus meet more demand. And as you know, anyone in the public sector, that demand is limitless. So this is to me, this is the reverse. This is job security for those who can leverage these tools, because you'll get better quality work over time. And I'm not trying to sell the tech. I'm really not. This is not what this is about. It's just trying to find ways to level up and be able to do more for our community in a way that's more sustainable. So that to me is the perspective. Again, just having managed, large departments and small departments, in every case, there's still so much work that needs to be done that now maybe with tools like this, you can have a little bit more time to do.
It's a supplement to, not a replacement for the planner.
That's right. That's right.
Okay, I know we don't have a ton of time left, so I do want to jump into some questions. This would be for Norman and David, both of you. I know you guys have done a lot of kind of learning and development on your own to understand this technology. Somebody asked if you could talk more about that journey. How long did it take? What are some of the lessons you've learned? And I know we've got a ton of resources throughout the presentation, but are there any in specific that you want to call out?
David, you want me to go first real quick? Okay. All right. So for me, I started working with this actually way back in grad school, when you think about it, because we would do in GIS these sustainability models where you would have criteria and models and weights, and we're to do suitability analysis on maps. And my point is just this: in some ways, some of what we're doing is stuff that we've been doing all along. If you've worked with GIS, if you've worked with even with Excel spreadsheets, there's an intuition to the work that we do when we're assessing cases or we're doing analysis that is present within these kind of models and the algorithms that they use. And so at some point, I'd say it was about really 2 years ago, when ChatGPT really came up and other models started to come up, I started to work with them a little bit. And that, again, 2 or 3 years ago, roughly. And you start to understand over time that what you really need is you need the rationale and the logic that we already possess when it comes to thinking like a planner. And then you need a little bit of creative writing expertise to know which words to say for which kind of prompts, or in the case of a algorithmic like deep learning model, you need to better understand the sort of things that we used to do in GIS all the time, and some people still do. But my point is just this: a lot of the base of the knowledge is already there. And then the technical element of trying to learn what to do and how to work with something like Midjourney or ChatGPT or any of these generative AI models of that sort, it just comes through trial and error. And honestly, for me, YouTube. There's so many people out there who can give you, you get it right there on the platform, any sort of advice that you might not be able to find from the APA passport classes or from the zoning practice articles. There's plenty out there, especially if you know how to look once you just start working with it. So I'd say for me, it's been 2 years. It's been trial and error, and it's been learning by taking everything from the APA that we can provide, as well as everything from the broader world of YouTube, for just learning how to do this stuff, period. So 2 years, and those are the methods. It's pretty straightforward for me.
David, what about you? You have anything to add to that? Technical difficulties in a tech session.
Yeah.
We'll keep David, we'll keep going, and then when you're ready, when you're ready, when you're able to, just go ahead.
Got it. I got it.
Okay,
Okay.
okay, good,
I
good.
the problem with Windows and looking at the questions and the answers and all that. I think this has been something I've been following for years, so it's a little different for me, and I've been more kind of interested in it from a data and application development perspective to some extent. But with a planning background, I do think about its implications for planning. I read a lot of reports that were more policy oriented in terms of learning how to use the technology. That came from just buying a subscription, seeing what it was capable of, reading reports of how people have tried to test it. But I already had a pretty large knowledge base personally beforehand when a lot of the Gen AI stuff started coming out. And there was a lot of research that I did as part of developing PAS memo 111, which almost it mentioned chatbots explicitly, and it just took off in a way that I didn't anticipate when I wrote it. But I think I would suggest experimenting with the technology. Like if you're kind of curious and you don't want to spend money, I would download LM Studio and play with some of the smaller models. If you can just pay for a subscription for a month, I think it's worth trying one of these other subscriptions. It doesn't have to be OpenAI. There are other providers like Claude by Anthropic and others.
Gemini, yeah.
And Gemini is kind of free to use for the time being. And then there's more and more integrations through Copilot. I think you're going to find more and more ways that this just becomes more accessible over time. But I think that's generally my experience has been kind of experimenting with different softwares to access the technology, reading about the distribution. I'm in way too deep. I wouldn't my path is not worth replicating. That's what I'm going to say.
All right, well, thank you both. That's really helpful advice. There was a couple of questions specifically about the VSR 3000, and I think it speaks to some of the larger applications of AI given where the technology is at today. So I'll just read one of the questions. Any model that would be used in this capacity would need to have its properties available for public review. So couldn't some enterprising land use firm tech guys use the code base to reverse engineer how to game it with specific phrasing or submission materials? And I'm thinking specifically about a Ford dealership and an airlines that maybe had this happen to them. Do you guys want to speak a little bit about kind of gaming the system, so to speak, with these technologies?
I have some thoughts on this. There's actually a YouTube video that talks specifically about machine learning attacks. If you look up on YouTube, this turtle is a gun, and as it relates to actually image recognition algorithms, there are various ways that people are finding you can either articulate prompts, and in the case of image recognitions, change or disturb the pattern of a physical object to confuse these models. These models are subject to attacks. I think I just want to say that out loud, and so everybody's very clear. They can be hacked. I think the Air Canada example is a good example of where the person in question had no intention of hacking it. They were just like, "Is this the refund policy? You told me this was the refund policy." And then another person tells them, "No, that's not the refund policy." That's like, that wasn't an attack, but it effectively invented something that it wasn't supposed to. I think if it was used in this way, I did see that question. Yeah, I think that's a real possibility. There would potentially, we already know that there's a very large field of land use lawyers and others who are optimized to like identify how to get a permit through phrase of variance, all this types of things that we consider in planning. And yeah, it's very possible that if you decided to replace your entire planning body with a chatbot, which again, we're not recommending, yeah, you would be subject to the same types of attacks that could be repeated. And the vulnerabilities would likely be common. I think it's worth understanding that these models are optimized to answer instructions and people's questions. And so a lot of the things that you see online of screenshots of these models messing up are because it's like, oh, I don't want you to feel bad about the response that I'm giving you. Like it's
Right.
they're surprisingly easy to manipulate. And so I think it's worth keeping that in mind if you start like presenting a chatbot to the public to talk about your zoning code. That's worth considering.
And another thing to add here too, just to reinforce what David's saying is that, yeah, I made a very important point to be able to say that, that this is an intermediate step in the process where, yeah, this can be all available online. It should be totally transparent if and when any of these models are put into a workflow. But what's even more important is that once it is incorporated into a workflow, it's not like David's saying, it's not the final output. It's going to generate something, and that something is going to be recognized as coming from that model, not coming from the planning department, not coming from the planning office. And effectively what it means is that there's a lot of engineers who don't do their own drawings, but they have to actually review those drawings. They have to actually approve those drawings, stamp those drawings before those drawings can be utilized out in the field or be reviewed and approved, et cetera. And if you yourself are not the one who's writing the report, you must at least be the one who reviews that report and makes sure that the writing there is and the recommendations, et cetera, are exactly appropriate to your legal framework, et cetera. Can someone hack that somehow? Maybe someone can also hack our current websites and do ransomware attacks. And there's so many ways in which all kinds of malfeasance can occur. So our diligence on those fronts are going to be just as important with this as with everything else.
I think those are great responses. So I know that our ending time was 2:30, and I know we still got quite a few questions. Christine, David, Norman, what do y'all think?
I think it's time to wrap up because it's Friday at 2:30. That's what I think. And there are a ton of questions. So I always say, you know what, folks, if you have a burning question, you can always just email me. And I would be happy to forward your question on to the appropriate panelist. So feel free to do that. Again, folks, just as a reminder, we're recording the session. We'll post it on our YouTube channel. It'll probably show up sometime Monday afternoon because it takes a while to process. And I will nab the slide deck from one of you and have a PDF available of the slide deck on our website as well. And don't forget, head over to our website to register for upcoming sessions, ohioplanning.org/planning webcast. Thank you to the technology division and to all of our panelists today and our host and all the things. We appreciate you, and we love having you guys on the line to talk about this stuff. I think that's it. So everyone, thanks for joining us. Have a great weekend, and we'll talk next time. Bye-bye.
Thanks,
Thank you, everybody.
everybody.
Thank you all.